Hi, Prof. We are Team 1, and this is our strategy for ad resource allocation. In 2023, a series of natural disasters challenged us to improve our disaster response. Our operational strategy is phased, focusing intentionally on evaluating our capabilities and progressively incorporating advanced data analysis and processing, including satellite image and real-time analytics. We navigate these challenges with clear assumptions, prioritizing areas where our ad, like food, medical supplies, water, and shifter, can be most impactful, supported by a robust operational data and our technological foundation features a hybrid database system that combines RDBMS and NoSQL for flexibility and resilience, ensuring data access even in connective compromised disaster. And this system is accessible through an API, enabling seamless on-ground operations and decision-making. Our strategic intent is to leverage data-driven insights across all disaster response phases, enhancing our efficiency and effectiveness. By adopting a HTAIM approach, we can aim for real-time data analysis, and this approach not only faces immediate disaster response, but also sets the stage for like a predictive analytics, preparing us for the future challenges. And our goal is not just to address immediate need, but to boost the long-term level of the affected communities.
Next, I will introduce the data sourcing, data tools, and all the other prerequisites the NGO needed to prepare such a data systems. So there's three key points about the data sourcing and storage. I will include how they acquire the data directly. NGO have different kinds of ways to collect data. They can collect them by themselves, such as the satellite image data through the aerial drones equipped with the cameras and sensor, or the social media data by referring to the professional social media analyst tools such as the data miner, the Crimson Hexagon, or go to the crowdsourcing platforms. And the prompt data in the affected area by setting up custom mobile applications in all the people entering the affected area so that they can be automatically become the delivery of all the data point. Also, NGO can accept the data by creating a relationship with the external partner. They can make the partnerships through the APIs, whether the RPC one or the RESTful one. For the satellite image data, they can use the geographic information systems such as the ArcGIS or the QGIS to manage them. And also for the document data, for the unstructured one, they can use the MongoDB. For the structured one, they can use the Oracle. And also a MySQL is recommended for them to do the web-based applications database management. And apart from that, all the techniques should be placed on cloud platforms from Amazon or Google because it's best for the NGO to save the computing sausage and the storage sausage. Next, I will introduce all the data tools needed to solve the concerns raised from the previous data sourcing and the storage process. So the first one will be the privacy and security concerns. We will introduce an end-to-end encryption and a data anonymization techniques to prevent any kinds of individual privacy information to explore from the data collection process. And also, a secure access protocols will be introduced. Second, for NGO to manage such a huge data systems, the centralization may be another problem. Also, if all the databases depend on each other, it will make the whole system too sensitive to any kind of little changes.
Bob. So I'll be presenting on how we utilization of a data warehouse. So we start to use this data warehouse to store and manage a large volume of data that were extracted from various sources as my teammates have presented. In example, we utilize EMDAT to extract the information about the disaster. Second hub, we utilize to take the image, let know locations, etc. So these data will then be utilized to further support data analytics to improve the NGO operation. So data warehouse is actually literally just a warehouse where it stores, where it allows users to view data across the organization and makes it easier for us to do business intelligence or analytics for it. So in this slide, we present more dimension side, which are things like that quantifiable, such as names, country, etc. In our group, we have identified 9 different dimensions that we can do analytics on, ranging from disaster to medical personnel. So I'll briefly run through. Disaster, we're looking at the types of disaster, so the things are group and subgroup, we should opting for EMDAT. Same goes for country, we're looking out for the, to see whether we can do the scale operation, so where the location of the country is. Status is if they have made an appeal or not for us to go in. Potential sites will be looking more towards the geographical data, such as the lat long. Logistics will be this logistics portion will be focusing on main depot logistics, while the shelter will be focusing on shelter logistics. Distributed materials will be on where these distributed materials have come to. Everything the medical personnel is more towards the particulars of this data where we are able to use for potential site selection. In example, the number of sure. For logistics, we're looking at measure the data that will be associated with logistics. So, in example, plenty of food distribution, clear of distributed water. For shelter, I'm looking more towards the personnel and the logistics within the shelter. So, things such as how much consume food, consume water in each of those they utilizing. For distributed materials, looking more towards maybe the total probably on average quantity of distributed food. If for impact, we're looking at the calculation of the impact scores. In example, we will have numbers and choices. Now let's assign. The result is because this allows for flexibility to any new data in the fast changing landscape. So it gives it's not rigid. It allows for non-rigidity. Next, it also allows for quicker addition of data attributes. In example, and also one of the consideration we have is that the response teams will actually work in silo, and there's possibility that there's no internet access. So even with no SQL, actually reduce to do data synchronization, which actually allows benefits to it. So our team see the benefits of no SQL in operational data. Similarly, we think we have five different documents that can utilize operational data. For geospatial, we're more towards the geospatial data that will collect, for example, affected areas, where the shelters, where the key installations. For patient document, it's more towards the records of the patient, so their medical history, if they sought medical attention in example. For logistics document, it's more towards the logistical information, so things like transportation, food distribution, inventory level, etc. The operational data, then the key release document. For it, it's more towards the shelter, best for shelter specific, and towards the inventory level of the shelters. And finally, for staff will be for the records of the staff particulars for them. Yep.
So now with the data warehouse that we have, I'd like to talk about what we're gonna do with the data so we can integrate data to improve operations. So the first part is camp management, where we have basically two features. First of all is the site selection for ACAMS. So here we'll be using data from the EMDAT project and also some real-time satellite imagery, and potential regions for ACAMS are identified based on disaster type, terrain, and also some physical conditions based on the data that we collected. And the second one is camp records and individual tracking. So here we'll be using data on individuals in the camp so that we can tailor aid efforts to individual needs and also ensure the safety and well-being of camp inhabitants. And the second one is aid and logistics management. So first of all, we'll use data analytics to manage the inventory of aid items and also optimize the movement of vehicles involved in the distribution of these items. The second one is real-time aid distribution analysis, where we'll be monitoring the capacity, demand, and also current status of each shelter so that we can ensure efficient distribution of aid materials. Apart from that, we also have medical evacuation and personnel management. So here we'll be using data on the location of medical workers and also those requiring medical evacuation so that we can plan and coordinate evacuations effectively. And the last one is the analysis of real-time logistics route selection. So here we'll be using geographic data and also some real-time condition data so that we can select the optimal path for logistics, and with adjustments made as necessary based on real-time traffic, weather, and also other influencing factors.
In this part, I will explain our consideration of data management system design. Our strategic intent is to leverage data-driven insight to optimize our operation across all phases of disaster response, from initial assessment and site selection for aid camps to the management of logistics and resource. By implementing a robust data management platform, we aim to achieve a granular understanding of the needs on the ground, enable us to allocate our resources more effectively and respond more effectively to evolving situations. Using CAP theorem could guide us to design principle of database management, understanding which aspect is more important for each user case. Considering the disaster response, we would want to ensure availability and partitioning at the expense of consistency in the data. Due to the instability of the network within the affected area and limited internet access due to potential infrastructure damage, it is more critical to maintain the operations and coordinations for the various micro teams to manage the area of operation. To manage more on groundwork requirements like updating the status, inventory of aids, manpower allocation, etc., we should emphasize availability and partitioning. For initial planning in the headquarters to identify the area of operation with the largest impact. Not having the most up-to-date data is not critical to the operation, given that the whole humanitarian aid exercise for a specific area can span a long time. Since the data accuracy is important to ensure the limited resources are directed to the right area, we should build a database management system that emphasizes consistency over availability in this part.
Okay, hello, I'm Kanwen. So I run through the database management system walkthrough. So this is the overview of our database design. First, we have the upstream that actually generates we get all the different raw data from the satellite and from the emergency database and all stored into the cloud. And then what we see there is what you see on the left hand side. Then we will start to have this data layer that we are going to demonstrate on the right hand side. So my groupmate has already run through the value of why we need to do that. So let's see how this actually works in the operation. So we will first actually have to build an ETL. So the first one is the EARD design. As you can see that we actually established the facts and time. I'm not going to show all the facts and time here, but the intention is to enable this self-service data analytics through this system. What you see that, let's say you have a business question to identify the severity of human impact damage in the region of Southeast Asia, which your company is, your organization is interested in. And the purpose is purely just for resource planning. So having a dimensionalized data, as you can see here, it will help you to easily unlock the the knowledge in terms of what kind of data attributes that you need to pull from the facts and time. In this case, you will see that I will need to get the total depth measure from the fact, and then I'll join it with a dim country with a sub-region maybe equal to Southeast Asia, and that gives me all the disaster that is within that location, and I do have the measure, whether I do the sum of average, that's something I can do. So, and the merit is that because of how this structure is, I know that, okay, what if I need to know the resource that's required, I can actually join with the dim logistic data, and then you can actually see that maybe this is the amount of food that I need to allocate for. So all these are actually pre-planned before you actually get this data into it, and then it became very powerful for operation. One thing I want to highlight is on the left hand side of this ERD, you see that there is this dim potential sites. So this is such data that is already mastered and already cleaned out directly from like the upstream, which is the static data, and then you can actually see that this is we can actually join it with our existing emergency database that helps you to not just see from the disaster perspective, but also from the lens of geographical status, like, okay, where can we deploy our sites and things like that. So all these all in the dimensional database. So it's also important to understand the connectivity between the different data layer, and here I want to demonstrate two different types, which is the ETL and the HTAP. So we want to rely on ETL, and that's really quick to market. We can actually employ AWS SageMaker, which is run on Python. This allows more robust way of taking in the different data structures and type to load the data into a correct form. If you are going for a low-code solution, you can actually use Alteryx to do that. To build a connectivity between the NoSQL layer and provide that data analytics directly. So we can actually adopt the HTAP to provide this real time. So this is a replacement of the ETL design, but it takes time to build. So this is recommended on the later stage of your development. So if we have a real-time analytics on the operational data and how we actually adopt this document data store, what you can see is just a demonstration of how the user can leverage on the data that is provided and then navigate through the crisis within the smartphone.
Our NGO is committed to advancing our disaster response capabilities through a strategic phased project approach. And phase one is our foundation. It started with assessing our current data management system and identifying improvement areas and establish benchmarks. And we assemble a dedicated data team and secure essential data sources and design a targeted data model. And this piece is focusing on developing and testing ETL pipelines to ensure data integrity. And moving to phase two is expansion and enhancement. We refine our approach by integrating unstructured data source like image and to enhance analytical capabilities. We also develop like dashboards for real-time insights and decision making. And the third phase is introduced in advanced analytics and real-time processing. And it is dedicated to implement HTAP technology and enabling real-time operational data analysis. We also face some trade-offs that shape our approach. The balance between real-time data and connectivity challenges in disaster zones is pivotal, and while offline capabilities offer a solution, they can delay crucial data synchronization. Moreover, the necessity for scalability to manage data surges must be weighted against the financial implements of our NGO. And implementing advanced features like HTAP enhance our operations but demands more time. And additionally, the integration of diverse data sources enrich our analysis but increase the compatibility of data management. And these trade-offs guide us strategic decisions, ensuring we remain adaptable and effective in our mission. So that's all. Thank you.
So that's it for our presentation. Thank you for watching, and please let us know if you have any questions.